Let us identify the result for x that can be found at 2, 0 as it being reflected 3 times along the gamma, beta, and alpha lines with the following description. Now for this, we know that for this specific direction vectors, our alpha can be found somewhere here, right? Somewhere in this direction, okay? Or let me do it again using a straighter line here. This direction here. Sorry for that. Okay? That is actually the direction for our alpha because this is where our pi is located. At the same time, all of these 3 points actually passes to the origin. So basically, they're all just similar to the same angles in the unit circle. As for 3 pi over 4, we know that again, it's also located here. Sorry for this. It's located, sorry for that, I am trying to draw here. We have here 135 degrees. Let me do it again. Okay, sorry. All right, 135 degrees. If my graph is correct, this is 435 degrees. That's your beta. That's the location of 3 pi over 4. As for pi over 4, its last location for your gamma is actually identified here. It's a 45 degrees. Okay, that would mean the point here is the reflection, meaning you're going to reflect this point x identified as 2 and 0. Okay, this is 2 and 0 here in this line, which is identified as your gamma because that's what we start here, and later on that reflection will be reflected to your beta, and then later on the beta will be reflected on your alpha because that's the direction here from right towards left. Now we can use here the triple reflection, or in this case the rotation of our the point is similar for more or less a rotation. You may use here actually the idea of the reflection of a point at an angle. We have 3 different angles here, or you can use the identity that we have proven already in the previous video. And we have here the reflection of your alpha, reflection of your beta, and the reflection for your gamma. For your x is actually equal to, okay, the reflection for your alpha minus beta plus your gamma for your x. Okay, or yeah, just in that specific order now. Okay, now take note that this alpha, beta, and gamma pertains to the angles in radian measure that you have here. As long as they're all in radian measure, then we have radian measure. If all of them are in degree measurement, so we'll be using degree measurement. Nevertheless, what we have here is the reflection of your alpha, which is your pi, minus 3 pi over 4 plus pi over 4 here. Later on, we'll return to x. Just simply simplify this first. That's actually pi minus 3 pi over 4 is pi over 4 plus another pi over 4. This is actually the reflection of your 2 pi over 4 or pi halves. In short, simply take the reflection of pi halves. Okay? So again, we're going to take the reflection of pi halves alone, and the formula for the reflection, okay, of your pi halves is equal to this notation. You have here the cosine. Your reflection is twice, right? Twice pi halves. You will have here sine of your twice pi halves. You have here sine of twice pi halves, and negative cosine of your twice pi halves. This matrix will be multiplied to the components of your x, and your x here is 2, 0. So your x is at 2, 0. So you have 2 here and 0 here. Okay, so first let's simplify the trigonometric functions on the first matrix. So that's actually cosine of pi, sine of pi, sine of pi, and negative cosine of pi. Still you have here 2 and 0. Cosine of pi is negative 1. Sine of pi is 0. This is 0. Negative of negative 1 here. So you have 2 and 0. So you will have here The next one here is negative 1, 0, 0, and positive 1 to be multiplied with 2 and 0. In short, the reflection here for the entire form identified earlier, pi halves, which is a combination of all of these three, okay, using the identity we have proven, okay, which is the reflection of your, again, let's rewrite all, alpha, okay, pi minus 3 pi over 4 plus pi over 4 is equal to, you will have negative 2 plus 0, and then 0 plus 0 here as well. Okay, so we can see that in this form we have identified, okay, our triple reflections, or three reflections in negative 2 and 0. It's on the x-axis. It's even on the equation of a line alpha, because in the first place, if you would like to reflect this along 45 degrees, it will be reflected here, still on the axis. On our beta, it will be reflected here, and for the alpha itself, it will still be reflected there. That is actually the result for this, which is actually identified as negative 2 and 0. This is how we solve the triple reflections for this manner using the identity we have proven. Thank you very much for watching.